Now let's continue on with section 3 and 4, which is simplifying a radical expression. So our directions say to simplify and assume that the variable represents a positive real number. So for example 1, we are given the square root of 32y to the 14th. Right. So going back to the multiplication property of radicals, in the previous video we used it for numbers, but the nth root of a times b, this also works for coefficients and variables. So in this case, I'm going to spell it out more. So first n, since there's no number in the square root, what is our n? Our n is 2. Okay, and then a in this case would be 32, and then b would be y to the 14th. Right. So the square root of 32y to the 14th, this can be rewritten as the square root of 32 times the square root of y to the 14th. And now we're going to look at each radical individually. So let's look at the square root of 32. Square root of 32, we want to find the greatest perfect square that goes into 32 perfectly. So the one way to do that is, so the process that I'm doing when I look for the first small number, this is for people who don't really know what perfect square, like right off the bat. So this is a good process to help you figure it out, right? But if you know right away, you can go ahead and do it. You don't have to do this process, right? So for the square root of 32, I'm going to look for the first smallest number. The first smallest number is 25. But when I divide 32 and 25, I don't get an integer. Since it's not an integer, I'm going to go to the next perfect square, which is 16. Okay? But when I divide 32 and 16, what is it? It's actually 2, because 16 times 2 is 32. Right? So how can I rewrite the square root of 32? I'm going to rewrite it as 16 times 2. Right? I'm just going to bring down y to the 14th, and we're going to look at that when we're done with the first part. So the square root of 16 times 2, I'm going to apply the multiplication property again. So the square root of 16 times 2, I can rewrite that as the square root of 16 times the square root of 2. And then bring down the square root of y to the 14th. Right? And then we already know, so what is the square root of 16? It is 4, because 4 squared is equal to 16. Right? When I look at 2, right, if you're unsure if we can simplify this anymore, let's look. We want to find the first number that is less than 2, but as you can see over here, our smallest number is 4. Since our smallest number, so there's no perfect square that is less than 2, except for 1 and 0, but those don't count in our case. So this is just square root of 2. Right? So now let's look at the square root of y to the 14th. So recall, when we do the simplified form of radical, recall the first condition. The radicand has no factor raised to a power greater than or equal to the index. So in this case, what is so the index is n. And then what is the power of y to the 14th? The power of y is 14. Right? But we don't want the power to be greater than or equal to the index. So 14 is definitely greater than 2. So what does that tell us? That tells us that we can simplify y to the 14th. Right? So how am I going to do this? I'm going to recall the property. So if I have the square root of a, this can be rewritten as a to the 1 over 2. Right? And then just because I'll tell you the general, which is the nth root of a, this is 1 over a to the n, a to the 1 over n. Right? So how can I rewrite this? I'm going to rewrite this as y to the 14th times 1 over 2, or to the 1/2. And now we're going to use the power of a power property of exponents. So bring down 4 square root of 2, and then y to the 14th to the 1/2, we'll multiply the powers. And when we multiply them, so 14 times 1/2 is 7. So this becomes y to the 7th. Right, this is our final answer. Normally it's not as common to keep the radical in the middle, so I'm going to rewrite it. Usually it's in the back. So I'm going to rewrite this as 4y to the 7th times the square root of 2. Right, that way there's no question what is in the square root and what's not. Now for the second example, example 2, we want to simplify the square root of 12y to the 21st. So again, let's apply the multiplication property. So the square root of 12 y to the 21st, that can be rewritten as the square root of 12 times the square root of y to the 21st. So now we're going to look at the first part, and we're going to try to see the biggest perfect square that goes into the square root of 12. So let's look at our table, and we're going to find the first number that is less than 12. In this case, it's 9. But 12 divided by 9 does not give us a whole number. So then we're going to go to 4. And then what is 12 divided by 4? That is 3. So because 4 goes into 12 perfectly, that is the perfect square that we want. So we're going to rewrite the square root of 12 as 4 times 3. Again, I'm not going to do this part yet, so I'm just going to bring it down. One thing I want to add, though, is that if you want to, like for example with example 1, if you wanted to go ahead and tell me y to the 7th, let me show you, like y to the 7th right here, instead of this, that's perfectly fine. Right? Or you can start the work of like the y to the 14th to the 1/2. Right? You don't have to wait to do this. But for our sake, I'm going to do this step by step. Right. So now let's go back to our example. So the square root of 4 times 3, I'm going to reapply the multiplication property. So this becomes the square root of 4 times the square root of 3. Okay. And we're going to bring y to the 21st down. The square root of 4 is 2 because 2 squared is 4. And then for 3, so there's no perfect square that is less than 3 besides 0 and 1, but again, that doesn't matter. So this is just the square root of 3. And then now let's look at y to the 21st. Right. So again, 21 is way bigger than our index 1. So when I talk about the index, okay, since it's 2, what is the only option this can be? The power can be. The power can either be 0 or 1. These are our only options for this to be. Right? So I'm going to rewrite this as the greatest perfect square. Right? So how am I going to do that? I'm going to rewrite this as y to the 20th times y. Right? Recall, so if I have y to the 20th times y, this is the multiplication property. So if there's a y, what is the exponent? It's 1. And so since they have the same base, I can add the exponent. So this becomes y to the 20th plus 1, which is y to the 21st. So as you can see, this is the exact same as this. Right? So now let's rewrite it. So this becomes 2 square root of 3, and then this becomes the square root of y to the 20th times the square root of y. Bring this up. Right. So the square root y to the 20th. What is that? I can rewrite this as y to the 20th to the 1/2, and then bring the square root of y down. Right. When I multiply the exponents, y to the 20th times 1/2, that is 10. So this becomes 2 square root of 3 times y to the 10th, and then y to the 1st. So the power here is 1, the index is 2. 1 is less than 2, so therefore this is as simplified as it can get. So we're just going to bring that down. So this is not our final answer. We're really, really close, but we're going to combine the terms that are outside, that don't have a radical, and then the ones that do. So I'm going to bring 2 and 10, so this is 2y to the 10th, right? So, and then why can I move these factors around? It's because of the multiplication. It's because of the commutative rule, right? It doesn't matter which order they're in. So now I have the square root of 3 and square root of y, right? We just want one square root, right? So recall the multiplication property, so it's the nth root. In this case, n is 2, so I'm just going to do the square root of ab is equal to the square root of a times the square root of b. Oops. Right. So what we've done so far is we've broken it up to where like the square root of a times b is equal to the square root of a times square root of b. However, we can actually go this way as well. So if I have the square root of a times the square root of b, making sure that they have the same index, I can combine it, right? So the square root of 3 times the square root of y, what will that become? It becomes the square root of 3y. And this is our final answer.